very much. Well, that was a very interesting poll. I didn't know they were doing that poll just before I got on the stage. So it was what, 15% deep learning and 6% AI. Interesting. So I'm here to talk about driving high-impact business outcomes from artificial intelligence. And there is a lot of hype around AI. And interesting, though, it looks as if not a lot of people are doing much in their business. When we think about AI, we think about robots doing more complicated tasks. And some people think about robots taking over the planet. We think about machines beating the chess players, the Jeopardy players, the Go players, not to mention the professional Othello players. We think about autonomous cars. I think you're going to get a demo on that just shortly. And we think about Alexa and Google and virtual assistants in our homes. But businesses are using AI to drive better insights, make better predictions, and get business value. And they're doing that today. So I'm going to talk about a couple of examples. I'm going to talk about some of the challenges, and I'm going to talk about some tips for your own initiatives. First, just a few words about Teradata. Most of you know us as the enterprise data warehouse company. Teradata's mission is to empower companies to achieve high-impact business outcomes through analytics at scale on an agile data foundation. Teradata works with some of the biggest brands to solve their biggest problems, things like product innovation, operational efficiency, risk management, and they do that through analytics on a scalable foundation. And that scalable foundation is made up of fit-for-purpose environments like HDFS, object stores, and relational stores. In addition to that, Teradata Consulting works with customers to create analytics, and increasingly, those analytics is being driven by AI. So why has there been such an insurgence in AI? Why not back in the 60s when neural nets were first very popular? Well, it starts with an explosion of data. As most of you know, this has been happening for a while. Companies are storing massive amounts of web data, operational data, sensor data, including images and sounds. Deep learning models or neural nets require massive amounts of data to be effective. In fact, the more data you provide them, the better they perform. And previously, there just wasn't this kind of data available. There also wasn't enough computational power available. Today, we have GPUs readily available. GPUs, which were designed for video games, are also very good at the type of computation that neural nets and deep learning models require. In addition to data and computational power, there's just been a lot more research. So we have much more sophisticated models. One of the reasons why there's been a lot more research is that we also have publicly available labeled data, which makes it easier for more people to be able to experiment and train models. There's also been a lot more investment in industry across the board. As you know, businesses are investing in it. That poll seems to say otherwise, but businesses are investigating AI and trying to keep pace with their competitors. But there are very serious challenges trying to deliver enterprise AI. First, you need the right strategy. Businesses need to be able to pick the right use case and navigate between what's hype and what's real. They also need to have the right capabilities to support an AI initiative. And they need to be prepared for some business process changes. And the technology is still evolving, and the pace is extremely fast. Some of the best innovation is coming out of open source and academia, so ease of use and maintenance might be a bit of a challenge. And you're probably going to hear this from me a few times in the course of this talk, but it's one thing to be able to train a model. It's quite another thing to deploy a model into production. And there's much more challenges in deploying a model, integrating with business processes, and integrating with operational systems. It's also a challenge to be able to monitor your model, be able to retrain it and redeploy it at the pace of whatever problem you're solving within your governance framework. And then there's data. I think a lot of people have heard deep learning and neural nets don't require feature engineering or data preparation. Well, that's true for some problems, but a lot of problems that businesses are trying to solve, you still need to be able to integrate data across your silos, you need to be able to create features, and you need to process the data so that you can input it into a deep learning model for training and for inference. And of course, you have to do all this in a shortage of talent, which isn't a surprise seeing as it's such a hype field and still emerging. So let me give an example. Let's take an example of an operator or a manufacturer of an expensive asset, like a jet engine. They want to be able to predict when the engine's going to fail so they can produce some preventative maintenance and avoid some unscheduled downtime, which costs them money. So they collect information like maintenance records or operational data like when the jet was flown. They can even take sensor readings of parts to see if they're hot or sensor readings of the vibration. And they can build a model in order to predict failure, and this is very valuable. But with AI, imagine we can put a camera in the jet engine, and now we're going to take images of the hoses or the belts and use AI to see if we could detect a crack. Or we could put in something to monitor the sound of the jet engine, and we can use AI to listen to see if we can hear a part that's having excessive wear and tear. So now we're getting better insights, and we can take better actions and get even better outcomes. And imagine that we could do this better than a trained mechanic, and we can do it faster and more often. My next example, I'm going to talk about fraud. And in the previous example, we used images and sound to improve upon the current analytic approach. And in fact, a lot of the breakthroughs in the research has been in the area of computer vision and sound, NLP, speech recognition. But again, a lot of problems with businesses aren't like that. The data's not uniform. In the case of images, it's just pixels being inputted. You take fraud, now we're looking at transaction data, and we're looking at customer records, and it's not the same. So the question that we get over and over again is deep learning better than other approaches like machine learning? So for fraud, the problem is the fraudsters are just too quick at coming up with new schemes, and they're very good at hiding what they're doing. And so the traditional approaches like rules engines just can't keep pace. And so the problem is a fraction of the fraud is caught. Majority of the cases that do get investigated turn out not to be fraud, and the problem just gets worse and worse. So in all the projects that we've worked with banks on to detect fraud, what we've found is that there's actually a correlation between the transactions leading up to a fraudulent transactions. And deep learning models are, in fact, able to learn that pattern and help the bank detect fraud. And we've tried lots of different architectures. We've tried feed-forward networks. We've tried LSTMs. We've tried convolutional neural networks. What I'm showing you here is actually how we've taken a series of transactions and some of their core features, and we've laid it out in a two-dimensional space like an image, and we used a convolutional neural network in order to detect the patterns. And as you can see here, what we've done is a depiction where we have colored some of the filters red or blue, depending upon whether or not they were fired, and you can see visually that there's a difference in these transactions between the fraud and the non-fraud. And indeed, here are the results. The machine learning ROC curve is in blue, and the deep learning curves, as you can see, have higher true positive rates, a larger AUC. And also, you can see there's a steeper incline in the false positive and the low false positive, which is very important. And the rules engines there far on the right with a much higher false positive and lower true positive. If anyone wants more detail about this particular use case, I am talking about it later this morning, and I'll go into even more details. What we've also seen is that you can combine these models and detect different types of fraud. You can combine rules engines with machine learning, and we've seen as much as a 50% increase in fraud detection and a 60% decrease in false positives. So here's some tips for your own businesses. Always start with identifying a high-value use case that you can deploy readily, easily. Think about areas where there's proven applications and proven research. Deploy the model, start getting business value, and build from your success. Don't get stuck in a science lab just training models. Think about having to experiment with lots of different types of architectures. Some cases, it's going to be quite obvious which one to use, but a lot of business problems, you're going to have to try lots of different architectures. If you've prepared the data properly, then the process of training models is relatively easy. In fact, you should be able to automate the process of selecting architectures and doing the tuning. And then finally, I'll say it again, It's relatively easy to train a model. It's quite a different thing to put it into production. So think about how you're going to operationalize the model early on. Have a clean line of sight into how the model is going to be deployed. Think about the architecture, because that's going to impact how you do some of the modeling and the design. And then finally, I'm going to leave you with a quote. This was from the Harvard Business Review in 2017. Over the next decade, AI won't replace managers, but managers who use AI will replace those who don't. Thank you very much.